Welcome dear students, and let us see, before going to start the third exercise. Already we have completed two exercises in the very first chapter, real numbers, and before going to start the third exercise, let us see some concepts related to third exercise. So there is a theorem. Before going to start third exercise, before third exercise we have a theorem. What is the theorem? Let us see. Let x be a rational number. You take x as a rational number and whose decimal form terminates. The rational number must be, if you convert the rational number into decimal form, that should be terminates. Then x can be expressed in p by q form. The number can be expressed in rational form p by q form. P, Q are co-primes. Yes, there are no common factors for P and Q. They are co-primes to each other. Prime factorization of denominator Q. The prime factorization of denominator Q must be in the form of 2 to the power of n and 5 to the power of m. If you find the factors, prime factors of the denominator, you must get either 2 or 5s. They should be in 2s and 5s. Otherwise, it won't be terminated. So let us check. And here n and m are non-negative integers. Yes, the exponents n and m should not be negative. They should be positive. Let us check one example problem. Yes, first one. For example, it is you take 5 by 4. Yes. Let us see, this is p by q form. Here xb is a rational number. For example, this is a rational number which is in the form of p by q. Is it terminating or not? Let us find. So first of all, convert this into decimal form. Yes, we can. 5. We have to divide by the denominator 4. 4 ones are 4. 1 is remainder, decimal point. 4 2s are 8. And again we get 2. Already we kept a decimal point. For that you can take 1 0. 4 5 is a 20. So here when you get remainder 0, then you can say that this is terminating. What is this? Terminating. This is a terminate. Yes. Rational number whose decimal form terminates. This decimal form is terminated. But what is the formula here? The concept. Please keep in mind, my dear students. The denominator should be factorized. Let us factorize. What is the denominator? 4. Here, denominator is 4. What are the prime factors of 4? 2 into 2, that is 2 square. Here, the denominator is expressing only in 2 power n. There are no 5s, no problem. According to the formula, according to the theorem, the denominator factorization must be done. In the factorization, the denominator factors must be in the form of 2 to the power of n and 5 to the power of n. You should get only 2s and 5s. We have got 2, all 2s, 2 square. So, if the denominator is in the form of 2 to the power of n, you can say that it is a terminating decimal. We have got the same answer. By division also, we got the same result, terminating. So, this is the theorem. Let's go to one more theorem. Yes. Let us see one more theorem. Here the theorem is, let x is equals to, take any rational number first of all which is in the form of p by q, such that this is a p by q is a rational number such that the prime factorization of the denominator q is of the form 2 to the power of n 5 to the power of m. 2 to the power of n into 5 to the power of m. Where n and m, these exponents are non-negative integers, then x has a decimal expression. So surely you will get decimal expression which terminates. Let us check one question. Here for example 3 by 8. Yes, 3 by 8. Let us take the 3 by 8. So first of all, what should we do? No need of doing division. Just to find the prime factors of denominator. Here, what is the denominator? 8. What are the prime factors of 8? 2 2s are 4, 2s are 8. So this prime denominator is expressing in the exponential form with 2 cube. So According to the formula, the denominator is expressing in 2 to the power of n form. Exactly. So either 2 or 5, or you can get both the factors. But other than 2 and 5 should not get. If you get other than 2 and 5 in the prime factorization of denominator, then that rational number won't be expressed in terminating form. You will not get terminating decimal. So here clearly, very clearly, this expression, this rational number gives us terminating decimal because of the denominator is expressing in 2 to the power of n form. So now let's enter to the third exercise problems. Yeah. Let us see the first question. This is 3 by 8. What is that? What is that? 3 by 8. Okay. Let us convert this rational number into decimal form. Means we have to divide it. 3 should be divided by 8 table. It is not possible. Then it is lesser than, smaller than 8. So you should take one decimal point. For that we can take 1 0. Now 8 table. 8 2 is 16, 8 3 is 24, and 8 4 is 32 is greater. So you can take 8 3 is 24. And now we get 6 as remainder. Already kept a decimal point. You can take out 0. You can take 0. 8 7 is 56, and 4 is the remainder, and already kept a decimal point. For that you can take 0. Now 8 table, 8 5 is 40. Yes, the process is ended. We have got 0. Therefore it is a terminating. What is this? Terminating. But how do you check terminating or not? With the help of the formula 2 to the power of n and 5 to the power of n. We have to find the factors of denominator. Here, what is the denominator? Here, denominator is 8. 8 can be expressed as 2 into 2 into 2, that is 2 cube. 2 cube is which is in the form of 2 to the power of n. This is in the form of 2 to the power of n. So therefore 3 by 8 is a terminating. This gives terminating decimal. And coming to the second question, 229 divided by 400. First of all, find the decimal form. Convert into decimal form. The given rational number should be converted into decimal form. Here 229, the numerator is smaller than 400. You cannot divide. So for that you take one decimal point. You take 0. 400 table. This is 2000. 290. So therefore 400 table you can check by 5 times. 5 4 is 2000. We get 2000. And the remainder is 290. Already we kept decimal point. So for that you take 0. Now you need 2900. 4000 table 7 ja 2800. So you get 100 as the denominator. And already decimal point is here. You take one more 0. Now 4 table 4 2s are, that is 800, and finally 200 is a remainder. Already decimal point is here. You take 0 and exactly divisible by 5 table. 400 5s are, that gives 2000. So we have got remainder 0. When the division ends with remainder 0, then you can say that it is a terminating decimal. Now let us check by prime factorization. Here, what is the denominator? Check the denominator. What is the denominator? 400. The denominator is 400. Now find the factors of 400. Prime factors is 400 prime factors. You can take like this: 400, 200, 200, 250, 225, 5 5. Means how many 2s? There are 4 2s and 2 5s. Now it is expressing, the denominator 400 is expressing in prime factorization method 2 power 4 into 5 square, which is in the form of 2 power n into 5 power m. So therefore you write the solution, final statement. Therefore here this decimal form is a terminating decimal. This gives us a terminating decimal because the denominator is expressing in the form of 2 to the power of n into 5 to the power of n. Coming to the third question, 2 by 11. So divide 2 by 11, it is not possible, which is smaller than the denominator. So take decimal point. 11 table, 11 ones are 11. You know that 20 minus 11 is 9. Already decimal point kept. So already we have kept the decimal point. Further take 0. 11 table, 11 8s are 88. You know that 90 minus 88, we get 2. And again decimal point is there. Take 20, means 0. 11 ones are 11. And again you get 9. Isn't it? You take 0. Already 90 is repeated. Observe here properly, my dear students. Here 90, again we have got 90. Means the process continuous. There will be no end. The process continuous, there will be no end. So therefore it is called non-terminating repeating decimal. So again you check 11 8 is 88. Isn't it? Again 2, again 0, 11 1 is 11. This process continuous means we get 0.181818. So what are the repeated digits? 18. The digits 18 are repeated continuously. So you can express that repeating decimals as 0.18 bar. 0.18 bar. So here the digits which are having bar will be repeated. Now you can say that this is not a terminating decimal. It is a non-terminating, repeating decimal. So let us check, let us verify by the formula theorem. Here, what is the denominator? What is the denominator? Denominator is 11. Can you write the prime factors of 11? Actually, 11 itself is a prime number. 11 itself is a prime number. It doesn't have factors at all. Actually, it is a prime number. Itself is a prime number. There are no factors for 11. So you cannot express in 2 power m n or 5 power m. So it is 11 power 1. That's all. So here the denominator is not. You have to write the statement here. Please write the last statement. What should be your answer? Therefore, here the denominator is the prime factorization of denominator. The prime factors of denominator 11 is not in the form of 2 power n into 5 power m. So therefore, the 2 by 11 a rational number gives us non-terminating or a repeating decimal. So this should be your answer. So my dear students, only one more question is left that you can do, because very simple questions, very simple formula that you try at your home. Okay, that's it. Let's continue the second bit now. Let us see the second bit of third exercise, and here in this bit we have to find whether the given rational numbers or given fractions are terminating or non-terminating repeating decimal, but without actual division method. We should not divide. In the first bit we divided numerator by denominator and we expressed whether they are terminating or non-terminating by actual division method. But you should not go for actual division method. Then only by using the formula what we have discussed, using the theorem, we have to express whether these are in terminating or non-terminating. Let us see the question number 1. This is first question is 13 by 3125. Here, what is the denominator? First of all, write the denominator. Denominator 3125. Yes, denominator is 3125. Let us find the factors. Factors of the denominator. The last digit is 5. Directly you go for 5 table. No problem. 5 6 is 30. 5 2s are 10 because 12 and 5, 2 is left. 5 5 is 25. And again 5 table. 6 first digit. 5 1 is 5. 1 is left. 1 2 means 12. 5 2s are 10. 2 5 25. 5 5 is a. And again 5 table. 5 2s are 10. 2 is left. 25. 5 5 is a. And again 5 5 is 25. Completely the given denominator is expressing in prime factorization only 5's are there. Here completely the denominator is expressing in 5's. The factors, all prime factors are only 5 as prime factor. How many times? 5 times. It is of the form, it is in the form of 5 power n. So therefore, you write the last solution. Therefore, 13 by 3125, the rational number is a terminating one. It is a terminating because the denominator expressing in 5's. And let's come to the second question, 11 by 12. And denominator, what is the denominator? 12. What are the prime factors of 12? 2 2s are 4, 4 3s are 12. It is expressing as 2 square and 3 to the power of 1. Is not of the form 2 power m into 5 power m. It is not on the form 2 power n into 5 power n because it is not in the form of 2 power n into 5 power m because we have not got 5 but we have got 3. So when you get other than 2 and 5 in the denominator factors, so it will not be a terminating. You can say that. Therefore, it is not a terminating decimal. You can write the answer. And coming to the question number 4, 15 by 1600. So 1600. What are the prime factors of 1600? Let us see. You can find by using tables. Prime numbers table. 2 8s are 0 and 2 table 2 400s are 800. 2 200s are and 2 100. You know that LCM method 250s and 2 table 225s and it is 5 square. So it can be expressed 1 2 3 4 5 6 times 2 as prime factors and 2 times 5 as 5 prime factors. Is of the form 2 power n into 5 power m. So therefore you can write, therefore 15 by 1600 is a terminating decimal. And coming to question number 5, 29 by 343. What are the prime factors of 343? You know that 7 7s are 49, 7s are 343. It is 7 cube. Actually is not of the form 2 power m n and 5 power m. Actually 7 we have got in the denominator. What are the factors of denominator? All 7s. It is expressing in 7 power something. There is no 2 5 7. When you get other than 2 and 5, surely it doesn't become a terminating, and your answer should be written here. It is not a terminating. It is a non-terminating repeating decimal. And coming to question number 6. Actually, you no need to find the prime factors. Already prime factors are given in the question itself. What is the denominator? Check the denominator. It is 2 cube into 5 square. It is 2 cube into 5 square. Already is in the form. You can write here denominator. You can write denominator is of the form of 2 power n into 5 power m. So therefore it is a terminating. Coming to question number 7. Here also already prime factors are given. Exactly. Yes. And here it is not in the form of 2 power m, 5 power n and something, because here 2's and 5's are there, but 7 is additionally we have got. When you get other than 2 and 5, just to keep in mind, my dear students, when you get other than 2 and 5, because even they are not divisible, they are not cancellation also. In cancellation also 7 is not possible to cancel here. So therefore, it is not of the form of 2 power n into 5 power m. Since 7 comes, so therefore it is not a terminating. Coming to question number 8, 9 by 15. What is the denominator? 15 is the denominator. What are the prime factors of 15? 3 5s, 3 into 5. Again, it is not in the form of 2 power m in n into 5 power m, because 5 comes, okay, but 2 is not there. Moreover, 3 is there. So since 3 comes, so it doesn't become a terminating. And coming to the last question, 77 by 210, and denominator is 210. What are the prime factors of 210? Let us see. 2 table you can take. Yes, 210. 2 table, 2 ones are 200, and 3 3s are 9, 3 5s and 5 7s. See here, the factors are 2 into 2 into 3 into 5 into 7. Yes, it is 2 square into 3 power 1 into 5 power 1 into 7. We have got 2 5, but additionally we have got 3 and 7. So since 3 7, since 3, it doesn't become a terminating. So just like this, you try to complete any problem once you go through the example problems also, but practice well. You may get in short answer type questions this type of very simple concept. Once if you practice, you'll become perfect surely. That's it.